The distance between 5 consecutive crests is 200 millimeters. So let's draw that. 1, 2, 3, 4, 5. So that is 1 wave, 2 waves, 3 waves, and 4 waves. So if this is 200 millimeters, then each wave is going to be only 50 millimeters long. But 50 millimeters is not one of the choices that you get given, so you're going to have to convert that into meters, divide by 1,000, 0.05 meters. Then it says the distance, they give that same thing, and the time taken is to complete a wave is 4 seconds. Calculate the period of the wave. So what they're saying is that one wave is 4 seconds, so that is the time taken for one wave is the period of a wave. That's the definition. So therefore, period is equal to 4 seconds, which means that the frequency is going to be equal to, is going to be equal to 1 over the period, which is equal to 1 over 4, which is 0.25 hertz. And finally, what is the speed of that wave? Now, speed V is equal to lambda F, and the lambda must be in meters, but we've already calculated that. The frequency must be in hertz, which we've already calculated, and you land up with an answer of 0.0125 meters per second. Another thing that you could say is you could say, I know that I am going to be, one wave has a distance of 0.05, and speed is equal to distance over time, which is equal to, and I know one wave takes 4 seconds, and that would have landed up being exactly the same answer. Then it says, calculate the wavelength of a wave with a speed of 40 kilometers per hour and a period of 3 minutes. So I'm going to have to do a whole lot of converting here. Minutes and hours are not compatible at all. I could, I suppose, change those minutes into hours, but 3 minutes in hours is actually quite tricky. So let's try and think of something else. Let's first do my kilometers per hour into meters per second. So it's 40 kilometers per 1 hour is equal to 40,000 meters divided by 3,600 seconds. And that is equal to 11,11 meters per second. 3 minutes, so period, that is the time taken for this. So period is equal to 3 times 60, which is equal to 180 seconds. And therefore, the frequency is equal to 1 over period, which is 1 over 180. And that is going to be 0.005555, so it's 56 hertz. Now I can work out wavelength. Wavelength is equal to V divided by frequency, and my V in this case is 11,11 divided by 0.0056, and that is going to be equal to, if you didn't do any rounding, you land up with 2,000 meters. If you get 1999,99 or 98 or whatever, you're close enough. You've done a bit of rounding though. The male speaking voice has an average fundamental frequency of about 1,500 vibrations per second. Calculate the wavelength of the male speaking voice. The speed of air is given at 331 meters per second. So I've got a frequency and I have got a speed. So I am going to now find out the wavelength. Again, wavelength is equal to V over F. So speed is 331 meters per second. And the frequency is given to me as 150 hertz. So divide by 150, and I land up with 2,21 meters. The wave motion illustrated in the sketch below completes one vibration in 0,5 seconds. How long will it take 4 complete waves to pass any specific point? Well, if one wave is 0,5, then 4 waves is going to take a period of time of 4 times 0,5, which is equal to 2 seconds. The wave motion illustrated below completes that. What is the amplitude of the wave? Well, if we're going from peak to trough at 20 centimeters, from the midline to the peak or from the midline to the trough is going to be only 10 centimeters. The wave motion is given. Determine the period of the wave. So one vibration period is defined as the time taken for one vibration. So it is 0,5 seconds. And what is the wavelength of the wave? Well, what have we got here? We have got one wave and half a wave. So 1.5 waves in 2 meters. But I'm not looking for 1.5 wave. I'm looking for one wave. So I divide that by 1.5. Divide that by 1.5. This is simple ratios. And I find that one wave has a wavelength of 1,33 meters. We're given the sketch again, and now we want the frequency. Frequency is equal to 1 over period, which is equal to 1 over, the period was 0,5. And therefore I land up with 2 seconds. And now what is the speed of the wave? V is equal to lambda f. I've got lambda, that's the wavelength, 1,33. I've got the frequency, 2 seconds, and therefore it's 2,66 meters per second when I multiply. The diagram below represents a transverse wave of frequency 30 hertz. What is the amplitude? Well, what have they given me? They have said to me that between peak and trough is 4,5. So amplitude is 4,5 divided by 2, which is 2,25 meters. Then they tell me what is the period of the wave. Period is going to be equal to 1 over frequency, which is 1 over 30, and that's equal to 0,03 seconds. What is the wavelength of the wave? Well, let's count out our waves over here. So I have got one wave, 2 waves, and a half wave. So it's 2.5 waves take 12 meters. Therefore, if I want to only know how long one wave is, I divide by 2.5, I divide by 2.5, and I land up with 4,8 meters for one wave. The diagram below represents a transverse wave. Calculate the speed of this wave. So the speed of the wave is going to be V is equal to lambda F. I've got the wavelength at 4,8. I've got the frequency. It is given to me somewhere earlier. It was actually given in the question, so it's 30 hertz. And therefore I land up with 144 meters per second. Now is an important question. At point A on the wave, is the wave moving upwards or downwards? So here's point A over there. So let's take a look at that very, very carefully. Here's point A. The next, as this wave is moving in that direction. So what is going to happen is point A, actually, this whole wave will have moved across. And what you're going to have is you are going to have this kind of an effect. And therefore, what's going to happen is actually point A will be at a lower point a little bit later on. So it is moving downwards. And that is quite a tricky thing to see, but you need to be able to see it.